Hi guys, welcome to another video. It's been 4 months, I know. I'm really sorry for the delay. I've been working so hard on that website, FoxyFi.cc. It's finally ready. It was a bit more daunting of a project than I initially thought. I looked into some new technologies that I had no idea how to work with, like NoSQL databases, doing some more modular type of web design, but it came out really well. I'll give you a little look into how it looks exactly. It's something like this. It came out super well. The site is fully ready. It is deployed. It has a web address. It's not secured because I haven't bought an SSL certification for it. That would be another step that I could look into and also make a video for you guys at some point, I guess. But it's going to be very interesting to do this entire series that I'm planning to do for you guys to teach you how easy it is to learn Python and how really anybody without any IT background can really get hands-on into something like this and start building it much faster than anybody would actually think that is possible. Most people will think Python is such a big and such a difficult language to learn. It really is not. It's something that looks a lot more daunting than it actually is. Python, for me, not coming from an IT background, I come from a hotel management background, believe it or not. I had no idea what a VLOOKUP function was in Excel, to give you an example. I had no idea what VBA was. I started working with that a bit when I started working in the financial services sector. And but it's really a marvel to dip into this programming language, because once you start it, you will see it's so much easier than if you look up Python online and you start looking into what would be required for you to learn it, right? Most of the guides out there, especially the written ones that you find when Googling how to learn Python, there's a lot of things that seem very daunting and very scary at the beginning. Specifically, what an integrated development environment is. So they'll make you install some IDE for short. You will have to install Python and choose between different versions of Python. To make it very clear, Python 3, stick to Python 3. Don't go with anything else. It's the standard that pretty much everybody's using. Just go with the latest version of Python 3 and you will be absolutely fine if you've already planning to install one. Then you go into virtual environments, how to set up virtual environments, so that'll make you open the terminal and start bashing some code into the terminal to install some specific things that maybe you are not even aware how to deal with a computer terminal, or how to deal with a machine without having a user interface and buttons to click that makes things so much easier these days, right? But let me tell you, all of that is not needed. I mean, don't get me wrong, you will need it at some point. You will have to learn what all those things are. But unlike most courses that want to teach you Python from scratch, and they do it very well, and start getting you used to these terms, an IDE and a bash terminal and Jupyter notebooks and virtual environments, throw that all away. What I want to do is I want to teach you a hands-on approach to make sure you can learn Python as fast and as quick as possible. And it is especially oriented if you work in any type of job within the financial services industry, but also if you work, let's say, like me, I come from a hotel management background, if I would work with revenue management. So any job that really requires you to work through data and present data in a certain way to make decisions or to make any type of data analytics, this will be the perfect base for you to get you started as quick as you can, without the trouble of going into any daunting subjects that might just demotivate you and prevent you from learning Python. The target here is really to give you a platform to stick to the basics and get a hands-on approach, which means I will show you the very basics of how to start coding in Python. So what a variable would be, what a piece of text is called, which is in this case a string, or what a number would be, a number without a decimal point, with a decimal point, how to store these things into different types of variables, into different types of lists of elements, let's say, and essentially give you a good base to start from scratch without the trouble of having to go through a huge course for many hours and learning things that most likely, in many cases, you might actually not even use. For me, what I did is I did a bunch of online courses out of my own pleasure, out of fun, out of interest, whatever you might call it. It was very useful for me, but in hindsight, it was really not necessary to do that many hours. In a couple of hours, the things that I still use today, or the things that I rather use the most today, they are still the same basics. They come down to the very elementary things that you start at the very beginning in Python, and that you do not need an IDE for. You do not need to learn any terminal logic for that, and you do not need to create any virtual environment either. You only need a browser, and we're going to use a tool called Google Colab. It's a fantastic tool. Let me show you what it is. This is essentially one of the things that you would learn if you would go into a regular, more in-depth Python course would be how to install a program called Jupyter Notebooks, which essentially is a browser version of an application running on your machine that allows you to execute Python code in blocks. So you would have essentially a line to execute code in, something similar to this. You could write code in here, and then you can just shift and enter, and this will exactly start running. As you can see, with Google Colab, you don't need to install any Python version on your machine. The only thing you really need, you want to start Python, you stick to this course, you look through the YouTube video, you open Google Colab, you start a new file, or you open this file that I will share with you in a minute. And all you need to do is shift enter and execute pieces of code. You can write here whatever you want. You could delete this and say print hello world as the stereotype, and this will print you hello world on the bottom of it. This is as simple as it is. It's very basic, I know. This is not Python in its bigger picture. It's only the basics of it, but you will always, and I cannot stress this enough, use these basics in whatever you're doing. You might be writing a huge block of code with 500, 1,000 lines, 5,000 lines for that matter. In those 5,000 lines, in every single line, most of the time, you will be using something that you will learn on the very basics of Python at the very beginning when you start your journey. To give you a little bit of a look of what you can learn in the long term, this is entirely built in Python. There is not a single piece of JavaScript that I have coded myself. The only little bits of code that are in here that are not exactly Python is CSS, which is very simple. It's only to style things like changing the background to this color or changing the nav bar here to a slightly different blue from this blue. The way the colors that things highlight, these icons, etc. The color background of these little notifications here. All this stuff is done through CSS, but it's only a part of it. Most of it is actually done via Python as well, and I will show you exactly how that is done in the long run if you stick through this series. So let's get right into it, shall we? So to give you a little overlook of the website, it came out really neatly. It has these tabs. You can collapse them, open them. It has a market overview tab. It has these little widgets that you can scroll through. You can click on them for more information. Right? You can click on there are links on these little notification bars here. You can click on them, and they will open you the specific ticker that you clicked on. In this case, SPY, with the latest bars. You can change these to 1 hour, 1 minute candle bars. You could have a graph instead of a candle bar graph. You can do comparisons between other indicators. You have a bunch of financial indicators in here as well that you could put and add in, like moving averages, as you saw, I just added it on the bottom, MACD, stochastic, etc. It has a little trading view widget for news. So for example, if you would have gone back and clicked on a specific company rather than SPY, so let's say AMD for this case, you will see the latest news on AMD coming from TradingView. It's very useful. At the very end, also there is a table that with all the trades that have been hypothetically put into the NoSQL database here that feed, in this case, for AMD only. So there is some logic on the back that when you open the AMD ticker, it will show you all the trades in the database that have been input by any kind of user for AMD. If you go back to the home page, at the bottom there is latest trades. It has all the different tickers. Could input more of them. There is the ability to log in. It logs you in. There's models popping up. When you log in, it gives you a little bit of a user interface, who you are, some emojis that you might get as prizes, etc. This is all it's all fake, right? There's no the data is real behind you. Don't get me wrong. The news are real. All these little things, these widgets, they're providing real data. But the trades, they're all fake trades. The followers are fake. The score is fake. The rank, win rate, etc. This is all data just to give you an idea of what it could do. You could add a new trade when you have a user here registered on this website. You can select the type of the trade. In this case, let's say a short position. You can click next. It will show it's a short position. We'll ask you for a ticker. We could say here we're shorting S&P 500. Let's say we're shorting 10. We're shorting at, let's say, 407. And we could add a comment. I am shorting this because I like to short it, for example. Yeah, it will update automatically here. When you submit, it will submit this trade, right? Close. And when we close this, closing, on the table on the bottom, you will see Foxy has now shorted position on SPY for 10 at 407, which has a cost basis of around $4,070. I could, at any point in time, click on the user to see a more specific in-depth information page on the user, which will show me the same information as stated here, with number of trades, average trade length, a little bio. I could edit my bio, for example. Hello, I'm Foxy. I'm showing you this, typo, showing you this site. Submit, close, it will refresh. And now, as you see, it has stored this in the NoSQL database. It's quite cool. This table, there's very different ways of creating tables. Tables with links is a bit more complicated. This is why it took me also a bit longer to finish this website. But I found a way to make it happen, and I'm going to show you how to do this as well at some point when we get deeper into more specifically Dash and Plotly and Bootstrap, Dash Bootstrap components. You can click on the trade, so short position. It will open the trade that I've just opened just now, as you saw, with the day I opened it and the time. There is no time close yet. The length, because I just opened it, there's a 0. The notes I just written. When I close this trade, it'll also allow me to put a closing price. Once you put that in, for example, let's say we shorted it at 407 and we bought it back at 405. We'll make a profit on that of $20. It will show you the P&L, $20 positive. If we would have shorted and sold at 410, we would have a loss of $30 and also a comment. All this logic, I will show you how this is built, how this is done. It's much easier than you think. These links going back, little learning center. It's essentially a very neat website. It took a bit of time to build because there was a lot of pieces that were new to me as well. Don't get me wrong, when you're very new into it, it takes a bit longer, and there's not a lot of guides that are specifically telling me how to build a custom-made table like the one I showed you, or how to import these widgets was also something new to me, or how to implement a NoSQL database in the way that I wanted to implement it. It's not as straightforward as that either. But once I dig into it, I try to make it as simple as possible. It's much easier than it looks. And I will show you how exactly to do it so that you don't have to spend hours and hours digging it out for yourself either. In any case, the purpose of this video is to show you exactly what you will be able to do in the long run, but to start with the very basics. So what we are going to do is I'm going to show you a little introduction into what Google Colab is. As I explained to you, this is an online Google version run in the browser of Jupyter Notebooks, which has the upside of you don't have to install any integrated development environment. You don't have to install Python in your machine. You don't have to install anything. You only have to open Google Colab. You need to have a Gmail account, preferably.
because it does store the files on your Google Drive. And once you have that, you go to Google Colab, you create a new file, and you get going. I can show you how this works. I could come here to File, New Notebook. It will load it for me, create it. That's it. You just give it a new name, you double click here, New Notebook, and you would click Enter, and it would be saved in your Google Drive as a new notebook. And here, as I showed you before, we can print hello world. All right, world. Shift Enter. It will initiate at the first time when you run it. It will take a few seconds longer because it's initializing the machine for you. So this is running on Google on their servers on a server machine, which has RAM and disk space. It will initialize the Docker for that, and then it will run the code for you. As you can see, if I would run something else now, like let's say 4 + 3, it is much quicker. All right, let me close this. We don't need that. Leave. If you want to search what Google Colab is, you can come to this website. You can Google Colab, leave. And when you open it, the first thing that shows up is your Google Drive files. You cancel this, and you can see a little introduction, what it is, how to get started, what it does for data science. As you can see, you can execute code. It creates graphs for you, machine learning examples, some resource overviews of projects that other people have done. It's quite interesting. You can have a read through it, or you can dig right into it, and you can open the Google Colab file that is on the link below in the description of this video, which is called Get Started with Python Today, to get right into it with me, okay? So what will we do? Python, as an introduction, this, as I explained, this is really oriented for people that are looking to work with data. What I mean by that is Python spans many different areas. You could go from controlling a little robot to the lights in your house with a smart device connection, or you can really go into controlling the camera of your computer, like I'm controlling the webcam right now. Not with Python, of course, but I could do it with Python, and I could make it do stuff like identifying signals with my hands to increase volume, decrease volume, create QR codes, edit images, all kinds of stuff, create a game. It's really infinite. The possibilities of stuff you can do with Python is absolutely unbelievably insanely large. But the focus of the course that we are building on FoxyFi here is really more data driven for people that are specifically working with data, especially if you're working in the financial services industry like I am in this case. Which means not only if you're an analyst on the front office side, and by that I mean if you are a stock analyst, or if you're just somebody at home investing on your own side and you want to do some analysis on that, or some financial analytics on a specific company, on some company statements or financial statements or balance sheets, etc. You could do that as well. We go over that as well. I have some courses done on that as well, and that you can find on my channel. Somewhere on the link below as well. And in this case, this specific course is really more driven to making decisions with data, or looking at graphs, or creating a full-blown application which shows you all the data and has all the back-end logic and front-end logic to create a website without needing the complicated parts of creating a website, which when you look into a course of doing that will involve HTML, will involve CSS, JavaScript, a whole lot of different technologies. Here we're only focusing really 99% of Python, 1% of CSS, just to make it look a bit sleeker, okay? But it's going to be 99% Python. And you will see that it's much easier than it looks. I cannot stress this enough. We are absolutely, in my opinion, of course, and feel free to have a different opinion of mine, but in my honest opinion, we are in a transition right now where Python becomes more and more important in the financial services industry. Being it somebody who does front office analytics to make decisions on whether the stock has a good entry point, or if they should close their position, or to do some forecasting,
in terms of revenue management, or to do some basic analytics in terms to retrieving price to earnings ratios, capital expenditure ratios, any kinds of financial analysis that you might want to do on a specific ticker, you can do with Python in the front office or also in the back office. If you are paying an invoice and you have a huge list of invoices and you want to be able to automate a process that is analyzing those invoices and categorizing them, for example. Or if you are looking at data that is feeding into a system and you have to approve every little bit of data, but the data is so spread out and so confusing that you want to make it look sleeker to be able to understand it quicker and faster, and you want to do that in an automated way, which would be more middle office focused, that you can do as well. Or you want to create a database and you want to store, I don't know, lines of credit, or you want to store specific trades and track them with specific user inputs, like saying they're okay or that they're checked or to be followed up, or you want to make a task list, or you want to make a to-do list. All these things can be done all the way to creating even a calendar where you can manage shifts for your team. I've done that as well. That's also something that you could do with Python from scratch. And all of this, you can conglomerate that into one web application, launch it, deploy it, and have it ready in any job, really, that is focused on finance. It's really absolutely mandatory, in my opinion, if you're starting a career in the financial services industry, be it in banks, be it in commodity chain, supply chain finance, be it in a hedge fund or a mutual fund, or even if you're working, I don't know, for the World Economic Forum or for, I don't know, the United Nations, for that matter. Anywhere where you deal with data, large sets of data, and processes become bigger and more complex and require more automation, which today is done with Excel, either by building complex spreadsheets with complex pivot tables, or even with Visual Basic, with VBA, to create some macros to automate a lot of tasks, which I've seen millions of them in the course of my career already. Well, not millions, but hundreds of thousands of them for sure, which compile millions of lines of code in VBA. VBA is an outdated technology. It's a slow technology. It has a lot of downsides. It's hard to keep track of what's done. It's hard to version control it. And by version control, I mean it's hard for you to build something today, maintain it for 2 years with all the changes that you've done, and track those changes accurately, so that when you leave, somebody else can come in and know exactly what has done over that course of period of time and understand the code the same way you did. With Python, that is a completely different story. We have version control, we have virtual environments, we have packages that are open source and maintained by a global community. And code is more readable. There are many colors, many different utilities that you can use to identify different pieces of code and different functions of different pieces of code. It's completely different, and it's absolutely, in my opinion, mandatory for anybody to learn. So if you're about to start a career in this and you have not started Python yet, it might not be mandatory for the job you want right now, but believe me that if you have that in your skill set, if you were here, you will be up here in the list of candidates. Because in the future, it will absolutely be mandatory to know Python. I can tell you that with 100% guarantee, hands down. I have no doubt of that. This is the language of the future for data science and data analytics. So let's get started with this course, shall we? I've built a little starter for you, which we will go bit by bit, hands-on, and I will explain exactly to you what is happening in each line in a slightly different way. What I mean by that is I'm going to try and explain it to you in a non-IT type of way as possible, if that makes any sense at all. And why do I want to do that? Because I came from a zero IT background, and if there's one thing I've learned is this is really a language for everybody, and as long as it is explained the right way, it makes it much easier to understand that it's a much less daunting process than it actually seems to be. And that's why I want to explain it to you in that way. So feel free to throw me any comments down below if you think something was unclear or if you want me to clarify. I tend to respond to every single comment. If you want to reach out to me through social media, you can do so as well. I can explain anything in more detail, whether it is in this notebook or any course or video that may come in the future, and any notebook related to any of those videos as well, of course. So the first thing we did, the stereotypical thing to do in Python, and you will see this in every course, is to open a terminal, or in this case, open a notebook, which we did in Google Colab, and do a print of the hello world statement, which makes your machine say hello world to you. All this is a function inbuilt by default into Python, which will print into your terminal whatever text or string or number you might pass into it. In this case, we put a string. This is called a string. Any type of text stored is a string. We will go more into strings in a little bit. And they are stored with quotation marks, either single quotation marks or double quotation marks. Wait, I'm already making a mess. Or double quotation marks. So we could easily come here, change them to double quotation marks. There we go. And execute the code. And we will print out exactly the same thing. Why is the print statement useful? It seems quite redundant, but in the future we'll see that this is probably the most raw and useful way to debug pretty much any bit of block of code that you might do in the future. So what I mean by that, you can stick in a print statement and print out the status of whatever variable or whatever thing, a list or string or whatever it is that you're trying to create into the terminal and see what it looks like to, in case you have an error, figure out what the error is exactly creating or what's exactly happening to whatever you're trying to create and where the error stems from. Debugging is quite often done with print. It's not the best way to debug, that's for sure. But as a beginner, it's the absolutely most raw, simple way to debug anything. Keep track of this. It's not a difficult piece, and it's a quite useful function that will show you in the future when we start having bugs with our website. That'll follow up on FoxyFi, and I'll start getting into some of the bits and pieces that I've done for that. This is one of the most popular and versatile languages. That's true for data analytics, data science, and machine learning, and also for the development of full-scale applications and to create automated workflows. I'm kind of repeating myself here, but I can't stress this enough. This is absolutely, for sure, the easiest programming language you can learn, and potentially the most complete programming language you can learn if you're not going in depth into any type of IT-focused or IT-oriented field. So if you are working in finance, whereas in middle, front, or back office, and you just want to automate a workflow or create an application or do some data analytics, there is no better thing than Python. There's hands down no better programming language. And usually the basics, we will start with three types of data. The most basic three types are strings, integers, and floats. What they mean are strings are usually pieces of information stored as text. As you saw before, they're either stored with double quotation marks or single quotation marks. Sometimes you might also find string 3 stored with triple quotation marks. Whatever is here, and you do that. And if you print string 3, it will print that. Yeah. There's a reason why you can use triple quotation marks, but this is a bit more complex than is needed to go into detail right now. The most important part that you really need to know is that a string exists. It stores information as text, whereas it is real text or a number. You could store a number as text in here. And if we look at the type of string 2, so in this case, we have stored this string into a variable called string 2. And when we print it out, it shows us it's a string. If we would remove these quotation marks and store it as an integer instead, the type would be an int for integer. If it were a floating number, so a number with decimal points, in this case, it would show as a float. We can access individual elements of a string, which means we could access any letter inside this string. This is an ordered string. Yeah, these are index positions, and in Python, indexes also always start from position 0. So what I mean is, this is not number 1 and the O number 2 and the M number 3. No, it starts from 0. S would be position 0, O would be 1, M2, E3. This space would be 4, T would be 5, and etc. So if we come here and we try to access, let's say, 0, 1, 2, 3, 4, 5, which would be the T, and we execute it, it will return the T, as you can see, from the string. Yeah, this is called slicing the string, or accessing an individual element of the string. If we want to slice it into a part of the string, a whole content part of the string, which means if we wanted to grab text example out of some text example, we could slice it from, we could divide the string into a new variable, we store it into a new variable, and say that the string would be created from this already existing one, which is some text example, and we would only want to store text example. To do that, we would find our index position of where this starts, which is T, so 1, 2, 3, 4, 5, position 6. Mistake, it starts from 0, right? So 0, 1, 2, 3, 4, position 5. So if we grab everything from 5 onwards and execute it, text example, that would return text example instead. Important to notice when you're slicing a string, if we only wanted text, so position 5, 6, 7, 8, we could not say 5 to 8. It would be 5 to 9, because when we are slicing a string, the first part of the slice always includes that part of the string, and the second part, the ending of the slice, excludes the part of the string. So what I mean is, if we did 8 here, right? Let me go back here. If we did 5 to 8, so 0, 1, 2, 3, 4, 5, 6, 7, 8, so T to T, this would only return text, as you can see, right? So if we say 5 to 9, which would go all the way to position 9, which is the space, so since it's non-including this space, it will return 5, 6, 7, and 8, and not include 9, which would return text. It seems a bit confusing. To be very honest, it is a little bit more complicated than it would have to be, but that's the way it is. And with practice, you will see this is not really a problem. So often cases, you will just slice something and go through some trial and error. So worst case scenario, you would try to grab text, and it will either come with text and a space or just text. And in this case, you just change the index position of where it ends or where it starts, and you will end up finding the piece of the string that you want to have. We could also join strings. So let's say string 1, in this case, is some text example, and string 2 is 6.0. We can join string 1 and string 2 with a space in the middle. And this can be done by using simple operation symbols like plus. In this case, we are the addition operand, right? So we are adding string 1 to a space and adding that to a string 2. So that would come out as, we execute it, as nothing. Oops. Can only concatenate string, not float. Exactly. Why? Because we have not re-executed it. So if I re-execute it, now it's stored as a string. Before it was as a float. I can show that again to you. We go back here. String 2, right now, the type is a float. And if we select this and add quotation marks to it, the type will be a string. So now if we re-execute this, some text example 6.0, as we wanted to have. So string 1, which is some text example, a space between, and 0. If we would remove the space, it would add it, but it would not separate the two strings, right? So that's why we have that little space. That's a little trick to just concatenate two strings without having them non-spaced. There are some functions you can use with strings. In this case, we have a string that we stored in a variable type that we call a. So a will be equal to the string hello. We could capitalize the string by saying a dot capitalize. Capitalize is a function that pertains to a string. So any string has the function capitalize that is executable for it. In this case, that is as that comes by default with Python. Anytime we want to call up a function from a variable, in this case our variable is a, which is a string. If you want to call a function pertaining to a, pertaining to this string, you would have to say a dot. Dot is what calls upon a function. We could have a dot capitalize dot and another function, and that would give us a multitude of functions being executed at the same time. But in any case, every time you want to execute a function, you would have to grab whatever it is that has that function pertaining to it and put a dot after that and call the function name with the brackets. The same as upper. Upper will convert the string completely into uppercase. Capitalize the string. The capitalized string will only capitalize the first letter. We have also the function replace, which also has the brackets, as you can see. And replace takes in two arguments separated by a comma. An argument is something that you have to give to the function for the function to execute whatever it is supposed to do. In this case, the function replace wants 2 bits of information. What is it? He wants to know what do you want to replace and with what do you want to replace it with. In this case, let's say we have hello, and we want to replace every L in the string hello, so in our variable a, which has hello stored into it as a string, and we want to replace it with L, and this L with brackets. So as you can see, there is a string here. We're replacing a string with another string, and in this string will be bracket ELL bracket. Another thing that we could do is we could strip a string. So if we would have this string here, which is world with spaces, so this has 1, 2 spaces before it, and it has another space after it. So 3 spaces that we don't want. So let's say we are using this string for whatever reason, we need to match it with another one. If we would match world with a space with another string that is world without any spaces, the match between those two would return a false match. So you would never be able to get what you want. So to get around sometimes dirty data that comes with spaces, it's very useful to have this strip function to strip anything that you might have, any string that you might have from any trailing or leading spaces that might exist, which is what this will do. So if we execute all of this, all right, this will first execute this first line, which is storing the string hello into a. It will print it with a capitalized A, which it did. Yes, hello, H is capitalized. It will print it completely in uppercase, which it did, hello as uppercase. It will print the same string with all the L's replaced by bracket ELL, which it did. Hello has 2 L's, so it's printed HE and then bracket ELL and bracket ELL twice, and the O at the end. It correctly replaced the 2 L's with what we wanted it to replace it with. And world, which is a new string that has nothing to do with this. We just passed in, as you can see, we're not passing A into here, we're passing a normal, regular string. We could say, from world, we could say blah, blah, just for that matter. And if we executed that, it would be blah, blah, without any spaces. As you can see, there's no trailing spaces before or after. Whereas here we had. Okay, that is it for strings. The next type of information that we have is integers. Integers are any numbers that do not have any commas or any decimal places in them. So 6 in this case, if you execute, will just be a 6. And if you do type of 6, it will say it's an integer, for example. And it's a bit redundant that I showed you this because I had the line of code written below for me. There we go. Type of 6 is an integer. If you had decimal points, this would be called in Python a float, a floating number. And in this case, if we print that, 0.5, and print the type of 0.5, as you can see, it returns a float, as I just showed you earlier at the beginning as well. The next type of information that I wanted to show you, I'm going to show you what Booleans are. So another type of information that we have, or another type of data that we have rather, that is not an integer, it's not a float, and it's not a string, is a Boolean type of data. Booleans are simple true and falses. So if I execute true or I execute false, this will return either true or false, which makes sense. I just wrote false and it returned me false. If I execute the type of true, it will return Boolean. So the same as above, we said type of 0.5 is a float, the type of true or false for that matter is a Boolean type data point. Why is this interesting? Because you can do relational logic and identify anything that you might want to identify based on whether the relationship with something else is true or false. So let's, for example, create two variables now. We'll create variable a, b, and if we want to do that, we have to separate them by a comma. So a, comma, b. The space is irrelevant, but for neat and tidiness purposes, we are going to keep the space. And we're going to say AB is going to be equal to true, comma, false. The comma again, because since we're separating the two variables that we want to create with a comma, we also have to give the two pieces of data that we want to store into them with a comma as well. So in this case, we're storing true into A and storing false into B. And then we want to print the logic, the relationship, the relational logic between A and B. And A or B, we want to see if not A, which means if A is anything or if A is false, and if A is different from B. So anytime you're comparing something equality would be, in this case, print A equal to B. So different from casting a variable. So when you're storing something into a variable, it's only with one set of equals. When you want to compare something to something else, it's if something equals something else. So that would make it a comparison. And to see if it's different from something else, instead of equals, you would have exclamation mark and equals, just like it is here. So if we execute that, the first print statement will say it's false. Why? A and B are not the same, so true and false are not the same, so it will return false. This makes sense. A or B will return true because one of them is going to be true. So when you say, is A, that can be either true or false. By default, the answer will be, it's true, unless we say it's false. In this case, we store two variables. One variable is true, which is A, and the other variable is the other variable is false, which is B. In this case, A would be true, B would be false. So either or A or B, one of them is true in this case. So if one of them is true, this will return true. In the first statement, A and B, we would need both of them to be true. And since one of them is false, it will return false. The third print statement, we're checking if not A. So this is the same as saying, is A false? A is true. So this will return a false because A is not A. This is really confusing. Making it simple, if I would say is A, that would only return true if A were true, which in this case is true. B, on the other hand, is false. So if I would say is B, that would return false because B is not true, B is false. The same using not. Saying not A will only return true if A is false. So if I would use B as an example here, because B has false stored into it, If I would say not b, that would return true. So if I write not b into it, as you can see, the third one returned true now. If we compare a to b and say, is a equal to b, this will return false, which makes sense because a is true and b is false, as by what we cast it into the two variables. If we test if it's different, this will obviously return true. 1, because when we compared it to see if they were equal, it said false. So this can only return true. And 2, because yes, they are not equal, because 1 is true and 1 is false. If we look into functions, once you know all the data types, the first step into coding something interesting in Python is doing your first function. In this case, we are going to create a function that is called square and create a function that is called multiply. Whenever we create a function is always created by starting to write define this function, define what function, define whatever name you want to call it. So let's say I'm called Silvio, define Silvio, and then you have to give brackets. And in these brackets, you can either pass some arguments, yes, or you can not pass anything. If you would pass arguments, these arguments mandatorily or preferably would preferably be passed into the function itself. So if you define Silvio without an argument, the function will still execute. Whenever I call Silvio, whatever code is stored into this function will execute. But if I say Silvio X, then I would probably ideally have X somewhere as part of my function. Otherwise, it's completely irrelevant to have it in there, if you get my drift. This might be sounding a bit confusing to you, but it will become more clearer as we execute these two functions that we create. In this case, we are defining square, so we called it square. We could have called it blah, 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 but in this case, it's square. And we're saying that square takes in an x. So whenever we call square, we can give it an x value, which obviously, if you want to square something, would be a number, in this case, an integer or a float. And we will say that this function, we end it with semicolon, and we say that this function will return x squared. So whenever we want to square something, square in Python would be asterisk, asterisk, and 2. So it's squared to the power of 2. If we had this to the power of 3, or to the power of 20 for that matter, it would also work. But in this case, we want always to the power of 2 because it's squaring the number. Another way to do that, I don't have to return immediately when I create a function. I could just say my new variable a will be equal to x squared, and then return a. That would be another way to write the function. But to make the code cleaner and save space, we are only returning the square number directly, without having to store it previously in a variable and occupying memory space for no reason. The same with multiply. We define multiply, and multiply, since we're not only squaring one number, here we are multiplying a number, we're multiplying one number by another number. So instead of taking only one argument, we're passing it two. Argument A and argument B, or in this case, value A and value B. And this will return A multiplied, which is only one asterisk, by B. So whenever we instantiate these functions, now we can call square, for example, and we can say square 2. 2 to the power of 2 is 4, so in this case it will return 4. The same thing would be 3. 3 to the power of 3 would be 9, and so on. If we want to multiply, if we only pass it one number, it will give us an error. You see, multiply is missing one required position argument, which would be B. We only passed it A, we didn't give it a B. So in this case, we're going to say 3 and 2, so A will be 3 and B will be 2, which will return 3 times 2, which is obviously 6. There we go. And if we did a square of 2 times 2, yeah, 4 squared, this would be squaring the function multiply of 2 by 2. So this function will return 2 times 2, which is 4, and and subsequently we will square 4, which will give us 16. So if we execute this, it will give us 16. As you can see, we have nested the function multiply into the function square. That's what it's called here. We are nesting it, and it's returning us correctly 16. To improve code readability, in Python, we always try to either code in the least amount of lines possible to make the code as sleek as possible without losing readability, which means without making it overly complex and complicated to the extent nobody else can read our code and understand it just by reading it, because that's the beauty of Python. Often in case, you can just read a piece of code, and even without any coding background, there are quite a lot of pieces in it that you can just understand by reading what the code is saying. In this case, let's see, print A. So we're printing A somewhere, in this case to the terminal, but you can still understand what print means. Or define and return something. It's not difficult to read. Python is quite easily readable. In this case, we said multiply and we gave it 2 arguments, yeah, but we didn't state what they are. It would be much easier if we said, when we call this function, instead of just giving it 2 and 2, to make it easier to read, we would say A is equal to 2 and B is equal to 2 in this case as well, yeah? Because then we know that we're calling the multiply function, and notice that when you double click on it, it highlights what you're calling, the function that you're calling. And since it gets A and B, we're saying that A in this case is 2 and B in this case is 2. But we could say it's 3 to differentiate them, which would give 6, and that would give us 36 squared. Yeah, because 6 squared is 36. Which is exactly what we showed here, yeah? All right, the next step would be going into some loops. So if you have some background into VBA, this will ring some bells. Loops are doing things in a loop while a certain condition remains true or false or valid in this case. The 2 types of loops that exist are while loops and for loops. While something is true or while something is valid or happening, execute a block of code. Yeah. For loop would be slightly different, which is for every something in a valid scenario, execute a block of code. So one is giving it an instantiated while loop. So while something is true, serve a pizza. And another one would be for every person in the room, serve a pizza, as an example, as a mundane example, yeah? To give you an example, in Python, we're creating what is called a list. A list is essentially a variable that stores a bunch of data elements in it, separated by commas. A list is always identified by being cast in square brackets. So these brackets here. And this list has 1, 2, 3, 4, 5, 6, 7 elements, which also start at index 0. So A would be 0, 1, 2, 3, 4, 5, 6. Yeah, 7 elements for 6 index positions starting as of 0. Here we have only strings stored into them, but that's not necessarily necessary. That's not necessarily necessary. That's not really needed because we could store whatever we want in them. We could store another function. We could store floats, 5.49, for example, or we could store an integer, 7. Or we could store true. Yeah, right? I removed here the comma. True. We could store whatever we wanted in it. We could even store multiply. Yeah, multiply and give it A equals 4 and B equals 2. We could store that into our list also. A list is just a number of elements stored neatly into one data set. And, this little data set is a list, and we were storing it into the myList variable. And then we're going to create a new variable, which is called I, and we're going to say it's equal to 0. And we're going to say that while our variable I, which is currently 0, is smaller than the length of my list, then execute this code. So 0 is currently smaller than the length of my list. My list has 7 elements. So if I would, this will return 7, the length of my list, 1, 2, 3, 4, 5, 6, 7 elements in it. So while 0 is smaller than 7, which it is, print my list at position I, which in this case is 0, because we're starting. And we're finishing the block of code. We're saying that I is now incremented by 1. So we could say I equals I plus 1, which is exactly the same as just saying I plus equals 1. So this is just going to add 1 to the existing I. So it would be 0 plus 1, which will now make I equal to 1. And then, since we're looping, it will go back to the beginning and check if 1 now is smaller than the length of my list, which is still 7, which is true. Then it will print my list at position I, which is now 1, position 1. So it would print B. And then it would add another 1 to my I, which is 1. Now I will be equal to, or I will be equal to 2. And we'll check if the number 2 is smaller than 7, which is the length of my list again, which is true, and it will print position index 2, which is C, and so on and so forth until it finishes. At some point, I will be equal to 7, which is not smaller than the length of my list, is equal to the length of my list, and the loop will break, and the code of block code will finish. So if we execute this, as you can see, it printed A, B, C, D, E, F, G, in every item of the list. If I would say while I is smaller than the length of my list minus 1, it will finish here. Because the length of my list is 7, and I'm subtracting 1 from it, so I want this number to be 6. So while I is smaller than 6, keep printing stuff. The same could be done with a for loop, which is for every I element. And when I say I could say X or A or whatever we wanted to call it. In this case, I'm going to say, let's change the variable. Let's say for every X in the range of the length of my list. So the range function, range of 7, will return a range from 0 to 7. So it will say 0, 1, 2, 3, 4, 5, 6, 7. Yeah? So what we're exactly doing here is the range of the length of my list. It's saying the length of my list is 7. So for every X in that range, 0, 1, 2, 3, 4, 5, 6, 7, print my list at position X. Yeah? So if I said from range 6, yeah, or 5, it will go from 0, 1, 2, 3, 4, 5, 6 positions. My list has 7 elements, so it will only print the first 6. So if I execute this, it will finish printing at the letter F. Let's see if that's true. Oh, sorry. Mistake on my end. Range is 0, 1, 2, it's not 0. Range would be 1, 2, 3, 4, 5, 6, 7. In this case, index 0. But since 5 is non-inclusive, so it would be from range 0 including up to 5. Non-including 5. So position 0, 1, 2, 3, 4, up to 5, not including 5. So A, B, C, D, E, which is exactly what happened here. So if we do length of, or rather, the range of the length of my list, yeah? So range of 7 would be 0, 1, 2, 3, 4, 5, 6. So we'll print all the way to G, because it's 7 elements, yeah? 0, 1, 2, 3, 4, 5, 6, non-including 7, because the length of my list will return 7. So if we execute that, as you can see, it printed the whole list, the same as it did with a while loop. So this is just ways of you creating a block of code and keeping it looping and repeating itself until a certain condition is no longer valid anymore. And then it passes to the next line of code or the next block of the code. Give you a few more examples of lists. You can store a list as an empty list. To do so, you would only declare your variable, whatever variable name you want it. In this case, I'm using underscores, which is underscoring variable names. You could camel casing, which is a variable name, where you camel case the first letter of the second part of the variable name. So in this case, variable name is 2 words, so the second word would have its first letter capitalized. Anyway, that's just details. Let's just keep it as my list, as an empty list. This would just return my list. So if I call my list, at any point in time, you can call a variable by just calling its name at the end. It will print out an empty list. If I wanted to store some elements, in this case, I'm creating again, I'm casting my list, but in this case, I'm putting 1, 2, 3 as 3 different elements in the list. Executed it. And let's say I want to append another element to my list. I want to add another element to my list. So I have 1, 2, 3 right now. I want to add the number 4. I could do that by saying my list, which is this variable, and call the function, again, using dot whenever I'm calling a function append, and passing it the number 4. If I do that, it will print 1, 2, 3, 4. As you can see, my list is now not only 1, 2, 3, but it's 1, 2, 3, 4. We can also access individual elements just like we did before when we looked into the elements of a string by looking into the elements of a list. Again, they are indexed from position 0, so 0, 1, 2. If I look into the position 2, which would be out of 1, 2, 3, 4, 0, 1, 2, so number 3, this should print out number 3. There we go. We can also slice through lists, just like we did with the strings, just pieces of the list. So this would be from index 1, including 1, all the way up to index 3, but not including 3. So 0 is not included in this case, 1 is, 2 is, 3 is not anymore. And anything onwards is not anymore. So 0 is not, 1 is, 2 is, and anything from 3 onwards is not. So 1 and 2, 0, 1, 2, this would print 2 and 3. So we execute it. As you can see, it prints out 2 and 3, which is the correct 2 positions, 1 and 2. If you wanted to call a slice of a list, so part of the list, as of a certain index position, so as of a certain part of the list, all the way to the end of it, how you do that is you pass in the slicing configuration. So you say my list, slicing it as of index position 1, but you don't give it any number as the end of that slicing, that index slicing. So that will make it go all the way from 1 all the way to the end of the list. So position 1 is 2, as you can see. 0, 1 starts here, all the way to the end. So if we would call that, it would print out 2, 3, 4, which it does, 2, 3, 4. If we want to relationally check if a specific element would be in the list, so if we said now, is 3 in the variable my list, and we execute, it will return a Boolean, which is true. Why? Because 3 is in fact in my list. If I said, is 10 in my list, it will return false, because only 1, 2, 3, 4 is currently in our list, right? So this would be a way to check if any elements, let's say you have a database with a list of users, and you converted a certain column of users into a list, and that list has 10 users. And you say one of the users is Silvio, for example. You want to test if Silvio is in that list of users. If any of those 10 users is called Silvio, this would return true. Otherwise, it would return false. That would be a real working example of this, which is something actually I work on a daily basis with. You can also call the function length and cast my list into it, and that will calculate the length of how many elements are in the list. In this case, we have 1, 2, 3, 4 as the 4 numbers. And it will tell us the length is 4 elements in that list. Another thing we do have is conditionals to test for. So if a variable is equal to 10, so if we cast the number 10 into my variable or into some number, and we say if some number, so we could say conditionals would be if something is true, then do something, else do this, or else if something else is true, do that, or else if something else is true, do this. So you could have endless conditionals in here. The same as with VBA, if you're familiar with that already, you can do if and else statements. So you can say if scenario A is true, then do something else. If scenario B is true, do something else. Else, if scenario C is true, go through that piece of code. This is very useful when you are looking at anything specifically, more specifically in data, where you want to do specific conditional tests. So if any number in a specific column is bigger than 100, then run all this piece of code into that part of some other piece of text or some other block of data. That would be an example. So in this case, we are casting a variable called some number, and we're saying that it is equal to 10. And where if some number is less than 0, we want it to print negative. In this case, that will not be true, so it will not print negative. It will test the second conditional. If some number is equal to 0, print null. But this condition is also not true. If we said, however, in this case, remember, instead of saying to test if something is equal, which is with equals, the two equal signs, we could say exclamation mark equals, which is to test if something is different from 0. This would return true and would make it print null. In this case, we want to test if it's equal to 0, which will return false because our some number variable is 10 and not 0. This will not execute print null. Else, if the variable is bigger than 0, print positive, which is what would happen here. So let's try to test if we put a minus before the 10. So we're storing minus 10 into some number. Then in this case, the first part of the conditional would be true because some number in this case is less than 0. So let's see if it prints negative. Boom, negative. If we would store 0, it would print its null because then this part would be this conditional would become true. Otherwise, print positive. Yeah, very simple if and else conditionals. If you want to store data, just we did into a list before, there is 2 other forms of storing data as well. One is called a dictionary, and another is called a tuple. A dictionary, the lists we already went through them, as you saw. And you can slice them. You can pop elements from a list, which means remove the last element. So in this case, our list has this item A33, so an appending list. If we pop it, there we go. Yeah, it would have popped the last element of the list, and it would have just printed it. So there is some other ways to store data than just lists. There is also dictionaries and tuples. There are some more examples of lists here for you to go run through if you want, but we'll go straight into the dictionaries because they are slightly different. So whereas a list is just a list of elements, a dictionary is a key value pair. So for every key, there is a corresponding value. So let's say I am 35 years old. So we could create a dictionary where it says Silvio, the key Silvio, is 35 years old. Below, we would have another key, which is, I don't know, John is 40 years old, as an example. that is a key value pair. For that key, this value is the corresponding value. So that is stored with these brackets here, this type of brackets. It's not square brackets, it's these, I don't even know what this is called, but this type of brackets, let's put it that way. And inside these brackets, instead of having elements just separated by commas, you have elements, and each element has a key and a value. So the key, which in this case is A, separated by a semicolon, and the value for A is first key value pair. In the example I just gave you with my age, it would be the key Silvio would be 35. Yeah, or in this case, not a string, but an integer 35. B would be this, and C would be this. So in this case, this dictionary has 3 key value pairs, where the 3 keys are Silvio, B, and C. Or if we go back on this, it's A, B, and C. And the values are first key value pair, second key value pair, and third key value pair. We could loop through this key value pair and try and print every key and every value. So we could go again, use our for loop. And in this case, we would say for every key and value in our A again, we store this dictionary into our variable A, dot item. So the function items, again, it's the function that looks through every item inside of dictionary. So it will return every key value pair. So in this case, it would return A, first key value pair, B, second key value pair, and C, third key value pair. And it will print A and print the key and print the value, and then print the key again and print the value, and then print the key again and print the value, and so on and so forth throughout your dictionary. Another thing we could do is we could say that the B key, if you want to replace, let's say we wanted to replace our second key value with a different value, yeah, we could say that our A at position B, or our A at key B, is now equal to the value change second pair, yeah. Give you an example, if we print just what we just said throughout the for loop, it will say the type of our dictionary. So it's a class of dictionary, so because we're printing it here. And then it's going through our for loop and printing every key and every value, key and value, key and value. If we want to change the value of our key B, we could just cast that A at position B is now equal to change second pair, and we could print that out. As you can see, when we print the dictionary at the end, you see that B is now change second pair. Or we could just write blah blah in here, so blah 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 blah. As you can see, it's now blah 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 in here. Yeah. We could also say that B, create a new dictionary where B is equal to another A, where the key another A is equal to the value A2, and the key another B is equal to the value B2. And we could now add this dictionary into our existing dictionary that we created above, and we stored in our variable A. And we could do that by calling the function, again, using the dots to call the function. And the function in this case is update. And into the update, we pass the dictionary that we want to update A with. So in this case, we want to update the dictionary stored in A with the dictionary of key values stored in B. So if we did that, as you can see, when we print A now, it will return a much larger dictionary where it has the first key value pair, the second one, the third one were initially in it, and then D as add pair because we added it here, and then another A and another B because we just created it and stored it into our variable B, and then updated our dictionary A with our dictionary B. If you want to iterate over a dictionary, you could just let's say we create a dictionary and store it into our variable d, and say that our dictionary is equal to the key value of person, which has a value of 2, our key cat with a value of 4, and our key spider with a value of 8. And then we can say, again, we could say blah, 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 blee, 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 yeah? But in this case, to make it just clear, we say for animal and leg, because it's going to look for key and value in our dictionary D, because we stored it in D, our items of that dictionary, so our key values of that dictionary, print, and we pass it a string, and we can pass these little brackets into our string, which the function format will automatically identify as pieces of the string that need dynamic formatting. So if I pass any value in here, the first value will be passed into the first set of brackets, and the second value will be passed into the second set of brackets, which is how you could create dynamic strings, yeah? So in this case, for every item, so 1 item, 2 items, 3 items, it will do 3 different prints. And the first one would say, a person has 2 legs. A cat has 4 legs. A spider has 8 legs. So let's see. There we go. Person has 2 legs. This is a neat way to create a for loop to update a dynamic string through a dictionary of key value pairs. A tuple is slightly different. So whereas lists and dictionaries can be updated, as you saw, we can add stuff, remove stuff. Tuples, you can also add elements and remove elements to some extent with a bit of a workaround. You can't really change any element. So they are immutable. I'm not going to go too much into detail. I'm going to leave this for you here because we are going to come back to this in the future. I just wanted to leave it here because it's something that every course goes through, but it's something you very rarely use. For example, in my use case, in most of the applications I've built, whether personally or professionally, the only parts where I use this is really parts when I need pieces of information that cannot ever change, that need to statically be stored in memory at any given point in time. And this would, for me, be, for example, if I wanted to store the username and some user key into the session that is logged in a website, the website, whatever website I might have created in Python, yeah? But when you log in, it creates a cookie in your browser with a session, and in that session would have your user and your user ID key, for example. Those two things need to stay immutable, so they need to stay unchanged for the duration of their existence in the browser, and that would be preferably stored into a tuple. That's the cases where I use it, so it's more for authentication or security reasons. But we will go in more into detail later. We went into some arithmetic operations, so as you saw, we added strings, we added numbers. Whenever you want to add a number, you just call a plus. So if you put it 12, it will give us 18. If you want to subtract 2 from 6, it will give you 4. Multiply would obviously, as we saw above, be with the little asterisk symbol. So if we want to have seconds in a day as a variable that stores the multiplication of 24 hours times 60 minutes times 60 seconds, this will give you the amount of seconds in a day, which is 86,400. A division would be called upon with a little, is it a bracket? Where is this? Well, with this symbol here. Pardon my ignorance, it's a bit late, as you can see. And again, checking for equality would be done by using the 2 equal signs, and which returns a Boolean again. If we execute this, 6 divided by 3 is a 2.0, so it will return a float. And if we check this, it returns true as a Boolean. And if we check if 6 is different from 4, it would also return true as a Boolean. And as we used above, the comparison operators would be smaller or greater, greater or equal, and this would print. In this case, if we create a variable a, which will test if 4 is bigger than 6, and then we print A, this would return a Boolean of false because 4 is smaller than 6. And B, if 4 is equal or bigger than 4, would return true because 4 is equal to 4. So if we print these, it will be false and true. There we go, false and true. And finally, next level after learning functions would be how to learn to create a class. This is something that I'm going to go more in depth in our next lesson. How to create a class. A class is essentially a compiled list of functions that execute within a mother function, let's call it like that. Whenever you call this class, which in this case we're calling greeter, the class of greeter, inside of it will have the function of greet. Yeah? So when I could call greeter.greet, because again, dots as calling the function, and greet is a function that is pertaining to the class greeter. So inside greeter, you would have greet. And init is just a way to initiate. I will, these instantiations and initiations of functions and so on, we will go into into bigger detail in a later course, because this is a very important part of object-oriented programming, which is where Python is very strong at. And it very well deserves one episode all on its own. So I don't want to just give you a little introduction into classes like this and leave you kind of pending in tandem with information that you won't really understand without me giving you more concrete examples. I will, however, finish this course with a little quick fun preview for you, stuff that you will be able to learn throughout the next courses as well. I will try to keep it fun at the end and try to give you a fun example of stuff that you can learn to do outside of the normal data analytics stuff that we'll be learning through this course. And in this case, I wanted to show you something neat, which is how to create QR codes. With Python, it's very, very easy to create QR codes. So there is a package in Python that you can import and install. In this case, to install a package is very easy. You just !pip install. This never changes. And you call the name of QR code. So if you say QR code Python in Google, as you can see, this is a Python package, which has a bunch of arguments and parameters and functions in it. Yeah, you could read through the documentation here to understand it better. But for us, we're only going to use the basics of it. And I'm going to show you how we would create a QR code to open the website I created. Yeah, this website here. And you can then test this with your mobile phone by opening your camera, just like I did, which I will show you as well. So we will start by installing QR code, and then we will import the package IO, which comes as default with Python, and import QR code, which we just installed, yes? And from here, we will create a variable called QR, and we will say that our QR code package, from our QR code package, we will call the class QR code, yeah, or the function QR code. And then we will say that our QR, which has a function add data, so this is potentially a class with a function add data in it. So we say that QR will add data and we will pass in our website. And here you could pass whatever you want. You can pass your name, you can pass, I don't know. Is it stuck? You can pass your age. You could pass whatever you want, really. We will pass in our website. And then we will instantiate a string f. So we will say our variable f is equal to the string IO. So the io.string.io function from our IO package. This is basically just encoding and decoding. Don't really look too much into it. It's a bit of a migraine. It's just try to understand it at a most simplistic level. What we're doing here is we're declaring two variables. One of them is the creation of the QR code, which is encoded into a certain string type or a certain data type. and then we are decoding it with our string IO as an ASCII type of data, an ASCII data type, output. So we're saying that our string f is going to be equal to our string IO function, and then we will call our QR variable, and we will call our print as ASCII type of encoding, and we'll output it as a string IO. And then from that, we will seek 0, the position 0, which is only going to have one position, but in this case, but we'll seek the position 0, and we'll print whatever is read out of this, out of our variable f. So this will essentially convert this website link into a QR code and print it out as an ASCII type value. So by doing that, we will have the equal amount of spaces, whenever we have a new line, maintaining the spaces and the distance between spaces and letters and so on, so that it creates a nice squared QR code. And here, in this case, if I were to open this, as you can see, show in browser, there you go. It nicely opened the link, and that's how you would create a QR code for anything that you want. That's as simple as that in Python, and similar to these, there are many other mini projects that I have ready for you for the next courses. I really hope you enjoyed the basics. It's very important that you go through this again. As you can see, it's much simpler to code in Python. You don't need to install anything, any programs, any libraries, any packages. You don't have to create any virtual environments, nothing. You need a browser, a computer, open the browser, have a Google account preferably, open Google Colab, and you can start coding. You can open this notebook, which I will share again in the link in the description below. Code along, review the video. These basics are very important. It's very important that you remember what a string is, what an integer is, what a float is, what lists and dictionaries are, because those two we always use. Tuples, not so much, it's just as an example. Learn what a basic function is. So by that is how you define a function, how you can give parameters inside and use them whenever you're executing the code inside a function, and then returning whatever the result of that function is. How to add stuff to a list, remove stuff from a list, from a dictionary, update dictionaries, all those basic things. Why? Because that's stuff we will always use, no matter what package of Python, whether if we are just working on a data set or building a new page on a web application, there is plenty of dictionaries to be used and lists, and so we will reuse and reuse them. So with practice, you will get to know them better, but try to practice them now at the beginning already. It will make your life much easier. And trust me, that's all you really need to know, because once you have these basics hard set into your Python journey, it will make everything that much easier to do. I hope you enjoyed this course. I will try to make the next video not take 4 months. No promises. No, I'm joking. The next video will be hopefully next week or in a couple of weeks from now. I have a lot of the recordings already done, but as you can imagine, it's just not just creating the notebooks and recording them. I need to work through them in the video editor, add all the transitions and so on, update YouTube. And I want to do it nicely and timed so that you guys have the best possible and easiest possible journey alongside me in this Python for Financial Services Dummies course. Let's put it that way. Thank you again for watching this video. I hope you enjoyed the lesson. I will try to get through these lessons as quick as possible. I've already recorded quite a few. It's just a matter of going through them on the video editing side and deploy them to YouTube, of course. If you like them, please leave me a like, press that subscribe button or the notification bell if you'd like to be notified when I launch new videos. Don't forget to visit our FoxyFi.cc if you want to look at what I've built, how it works, and what you could potentially be building in the future if you keep up with the different courses that I will be launching in the next few days, weeks, and months on this channel. And hopefully I'll see you on the next video. Thanks again.